Welcome to e-learning session. Myself Santanu Pathak, lecturer in food processing technology. Today we will discuss on unit operation of chemical engineering 1. In this particular session we will discuss about refrigeration cycle. Refrigeration cycle is a very important part in our food processing industry. Whenever there is a cold cycle or there is a bulk storage system, that is a cold storage system, wherever storage systems, that means this type of storage systems are there, refrigeration cycle is important. So we need to understand the principle and steps which is there in the refrigeration cycle. So here I have shown a schematic diagram for a refrigeration cycle. It consists of four stages. Number one, compression. Number two, condensation. Number three, throttling and expansion. And number four, evaporation. Now, gradually we will discuss each of the steps in details, and we will understand from where our refrigeration is happening. Let's see. Basically, this is known as vapor compression refrigeration cycle. The vapor compression refrigeration cycle involves four components. Number one, compressor. Number two, condenser. Number three, expansion valve or throttling valve. Number four, evaporator. It is a compression process whose aim is to raise the refrigerant pressure as it flows from an evaporator. The high pressure refrigerant flows through a condenser heat exchanger before attaining the initial low pressure and going back to the evaporator. A more detailed explanation of each steps will be there as follows. Number one, compression. The refrigerant enters the compressor at low pressure and low temperature. It is in a gaseous state. Here, compression takes place to rise the temperature and refrigerant pressure. That means from low temperature, low pressure to high temperature, high pressure. The refrigerant leaves the compressor and enters to the next step, that is your condenser. Since the process requires work, an electrical motor is required. Compressors themselves can be scroll, screw, centrifugal or reciprocating type. In this particular chapter, we are discussing about typical single stage compressor. In industry, somewhere single stage, double stage compressors are also used as per the load or duty. Second stage is condensation. Condensation means the condenser is essentially high heat exchanger, nothing else. Heat is transferred from the refrigerant to the flow of water. The water goes to a cooling tower for cooling. In the case of water-cooled condensation, note that seawater and air cooling methods may also play this role. As the refrigerant flows through the condenser, it is in a constant pressure. So there is no, what is happening? From high temperature to low temperature, conversation is happening. That means there is no change in pressure, only temperature drop is there. Third one is throttling and expansion valve. This is very important. When the refrigerant enters the throttling valve, it expands suddenly. So what will happen? Sudden release of pressure. Consequently, the temperature drops at this stage. Because of these changes, the refrigerant leaves the throttling valve as a liquid vapor mixture. So in the input, that is liquid, and output, it is a liquid vapor mixture, typically in a proportion around 75% to 25% respectively. That means liquid portion is 75% and vapor is 25%. Correct? Throttling valves, it has got two important roles. Number one, it maintains a pressure differential between low and high pressure sites. Number two, they control the amount of liquid refrigerant entering the evaporator. Now the fourth step, that is evaporation. This is the most important in terms of our usage, because here we are getting the cold air or cold portion. At this stage of the vapor compression refrigeration cycle, the refrigerant is at lower temperature than its surroundings. Therefore, it evaporates and absorbs latent heat of vaporization. Heat extraction from the refrigerant happens at low pressure and temperature. Compressor suction effect helps maintain the low pressure. So there are different evaporator versions in the market, but the major classifications are liquid cooling or air cooling, depending whether they cool liquid or air respectively. So these are the four steps which are there in a vapor compressor refrigeration cycle, where it is used in our food industry for cold chain, number two for cold storage, etc. Now we should know about the coefficient of performance. Coefficient of performance means nothing else. It is basically output divided by input. Now let's see. The efficiency of a refrigerator or heat pump is given by the parameter called coefficient of performance. C, it is generally called as COP. The equation is COP equals to Q by W. What is Q? Q is the useful heat supplied or removed by the considered system. W is the work required by the considered system. So this is the coefficient of performance. Now we should know few common refrigerants which is generally used. CTC, chlorofluorocarbon. Basically, it is not CTC, this is CFC. This is known to contribute to the greenhouse effect. HCFC, hydrochlorofluorocarbon, ammonia. Ammonia is widely used in beer industry and distillery units, etc. So this is all about the refrigeration cycle. Thank you. For any query, please email me at sp.fpt.arm @wbsct.ac.in.